So we are about to go live. It's in a few seconds. It's like almost there. So I'm going to break the timer and get started. I think people already have joined in. So let's go live. I'm going to switch this away from this screen and switch over to my main camera. That should bring it up here. And hi guys, everybody, welcome. We are starting the cloud seminar in 2022, and that's what we'll be discussing today, beginning with our first session. And a couple of tweaks I'm going to do right now to make sure that I can see the chats that are coming in. And yeah, people are joining in. So we have Troy, we have, let's see who else. Lots of people. It's hard to read names. Zachary. Okay. So, oh my God, it's a huge list. So I basically welcome everybody. Let's get this sticker out of the way. So the sticker goes away. There we go. And let me introduce myself. My name is Nilesh. I am the one that talks, and you guys type. You chat with me on the website. This broadcast is currently transmitting live. It will be recorded, by the way, so don't worry about it. This broadcast is going live on multiple, I think 7 or 8 social media channels. The companies that support live stream are streaming this. And for example, I'll show you where I stream it live is right on our website. So we are a streaming service also, right here. You can see that this broadcast right now is also showing up on the Cloud Genius website, right here. See that? And people are joining in and chatting and all that good stuff. And that is beautiful. So welcome everybody. Let me log in here. And so I log in using GitHub, and then I say welcome everyone, and that's the chat message. And that chat message should be able to pop up right here on the screen. And that's, by the way, this is a new software I just built recently, and so that allows me to grab chat from the website and bring it up like this. The sticker that you, no, not that sticker. This is so crazy. I'm looking at here, but it's actually here on the screen, and that's lateral inversion for you. This lateral inversion is like you look at the mirror. That's what's going on. So when I point this way, I'm actually meaning this way, and that's the ticker that I created like a few weeks ago. So yeah, that's enough gimmicks. Let's hide it. So what are we going to discuss today? It's about what is cloud computing, like basic fundamental definitions. So the first session, this is the first one for the cloud seminar. So let's begin with understanding what is cloud computing, right? So you go do what I typically do is do a search. Like, what is cloud computing? I hope you can see my screen. Probably not. Let me just switch over to my desktop. So I'll project my desktop to you. And what I'm basically doing is doing a search. What is cloud computing? So here are some results. And here you will see that, people come up with their own ideas about what cloud computing is. Like these guys, here we have the Amazon company. They came up with some definition of what cloud is. This is Wikipedia definition. This is Microsoft's definition. This is somebody else's definition. This is the Wikipedia again. And basically what happens is everybody and their brother, and some of these are big brothers like Amazon and Microsoft. So these big brothers, yeah, whatever. I don't care about them. What I care about is what is the standard. Like when we're talking about definitions, these companies are not defining the standards. This is not a company, by the way, Wikipedia, but it doesn't actually define a standard. They don't. So they have their own definitions of what cloud computing means, but I don't care. So what do I care about? Standards, like I mentioned, right? So in our country, in the US, we have a standards body, and so let's see what the standards body does. So the standards body is, as you may know, I think there are chat, already happening. So NIST, somebody already mentioned this. NIST is a standards body in our country, and that That stands for National Institute of something something. What is it? National Institute of Standards and Technology. That's the standard body that we have in our nation. And most other countries kind of sort of follow what the US does in terms of the lead that we have in technology worldwide. And yes, we do. US has the lead. And more importantly, the area where I live, Seattle, there are two big brothers, like Amazon and Microsoft, both giants in the space of cloud, are right here. So I actually call the Seattle area the cloud capital. That was a bad joke. But yeah, my company is here, so yeah, and so it is the cloud capital. At least according to me. But nobody cares about me. People care about standards. So this is a standard established under some government act. This is the standards body, US Department of Commerce, and they have come up with definitions for everything that they have, that they can think of. And so let's not waste our time in digging through where that definition is. Instead, we go back to searching. What do we search? NIST definition of cloud computing. So here we have the definition. So this document, it's a pretty boring reading, by the way. So here, that document, the PDF document, you can find it here, is where the NIST definition of cloud computing is hosted by NIST. And so it is freely downloadable. So let's go download. So I'll go to that PDF and bring it down locally. So I have a local copy with me, and I'll open the Finder and go to the download section where I can probably find this PDF file. So it opened up somewhere else. I'm going to bring it here, that PDF file, right? That's what I'm interested in, which is the definition of cloud computing according to a standards body. And so what happens? Who defines actually standards? Like standards actually brings in global experts on a topic, like for example this topic of cloud computing, and they bring in experts around the world who are supposedly have contributed to technology as such, and they will sit together, debate, deliberate, and come up with a standard. This is what the standard is. And as I already said, it's pretty long, pathetically boring reading. So I don't want to read the whole thing. Like what I'm interested in is straight away zoom into the section which defines the word cloud computing right here. That's the page that I'm interested in. So I'll go straight to that page and read. Yes, the standards have to be read. So I'm going to read. I'll not bore you with reading, but I'll actually identify some very relevant sections of this definition and give you live examples of what that means in real life. So here we begin reading. Cloud computing is a model for doing something, right? That's the something here. What are we doing? Enabling something, right? That's what it's model to enable something. So that's the essential definition. It's a model to do something. Now, what is that thing? So we know it's a model to doing something, enabling some high-sounding buzzwords, a lot of them, and it's a whole sentence. The two sentences, they're full of buzzwords. So we have to go dig deeper in each of the words that we have here and understand. So it's enabling a ubiquitous, convenient, on-demand network access to something. And when we read that something is great, but let's go understand these four things here. Ubiquitous, convenient, on-demand network access. What does that mean? Each one of these words, ubiquitous, basically it means anywhere, wherever you are. So if you happen to be in Zimbabwe or, North Korea, who knows, or India or Seattle, wherever you go, you will have access to this thing that enables something. We'll talk about that thing later, but it is ubiquitous, like wherever you go, doesn't matter. And eventually, when people will go to Mars, like Elon will take us there. Who knows, I might go. I don't know, I haven't decided. But if he takes me there, we will have a way to access the cloud from Mars. Yes, that will be there. Then we'll probably have a portion of cloud in Mars. And also, a connection back to the earth, the cloud in the earth. So we will have that. Basically, it's the internet, like internet extended to wherever we have, our, space travel equipment, like Elon's car probably has internet connectivity. I don't know, it must have lost the connectivity by now. But the idea is, once we go and settle in Mars, we will have connectivity to this thing over there. It will be ubiquitous. So that's the word. We got that part. Next, convenient. Convenient is actually exactly what it means. It's super easy. What does it mean? Literally, it means you open a browser and then you go access to some cloud somewhere. Like this cloud, for example, is the Google cloud, right? And this cloud, for another example, is the Amazon cloud. And so see how conveniently I can open up a web browser that connects me, logs me, actually I already logged in, logs me into a variety of cloud services, and I can just readily use them. So that's the idea behind here. In our definition, convenient makes it super easy. Open a browser window. That's one way to approach it. There are many other ways, and we'll actually hands-on go variety of ways. Convenient is the idea is it makes it super simple. I did not even have to get up from my chair to make this happen because convenience. That's the second word. Next, on demand. That means, literally means whenever I feel like. Middle of the night, 3 o'clock, I get up and I want to see how my applications are running in some cloud somewhere. Well, I can get up and log in and see, and that's the underlying idea. For example, if I want to start something in the middle of the night or during the day, it doesn't matter, on demand, whenever I feel like I want a new thing, I can do it. Like for example, I can go here in the Amazon cloud and get a new machine created like this, launch instance, and launch some machine. For example, here is the Ubuntu server. I can go and follow along these steps and I will have a new Ubuntu server ready for me conveniently on demand whenever I feel like. On demand basically means I want it now, I got it now. That's what on demand basically means. There is this song of some singer. So basically, I want it, I got it. That's the lyrics. So that's the on-demand idea. On-demand idea. I think it was Ariana Grande in Seven Rings. She sings something like that. I want it, I got it. That's exactly what on-demand is. The song is called Seven Rings. I don't know if you sing or listen to these things. It's American pop music, and the singer is Ariana Grande. So that's on demand. Whenever I feel like, I get it. And based on the network, meaning the internet connection that we have. So for example, here in my machine, I have a connection to the internet, and that you can see, examine like this. So go to the network, and here you will find I have this connection, this Ethernet connection connected to my my Ethernet card connected to my gateway, which is basically a enterprise router in my office, which I'll show you. We'll talk about networking quite a bit later on, but right now this is the network connectivity I'm talking about. I am on the network, on some network, and that's the idea. So ubiquitous, anywhere I want, convenient, without doing too much of effort, on demand whenever I feel like, network-based access to, and we'll now talk about this to what? All these things. We'll talk about that next. So we got the 4 words: ubiquitous, convenient, on demand, network-based access. So we got that part. Now we'll understand what is this to, connecting to what, and that substantially decides what are we talking about essentially in the essence of cloud computing. So let's go see that detail. To a shared pool. Pool means collection, like carpooling, car sharing, same idea. Pool of resources. So there are some resources of computing resources. They're shared like a carpool. So you put resources together and people can just conveniently access whatever they want on demand from any location, access that shared pool of compute resources. So who are putting resources in? There are people or companies that bring resources into the pool, and these are companies, and here are people who will access those resources. So that's the idea. So this becomes a cloud. When people are bringing stuff, pooling, like in a party, you bring your potluck to share, and everybody will eat that food. So that's the underlying idea here, is people are sharing configurable compute resources and making it conveniently available on demand access to that resource on a network anywhere people are. That's the idea. It doesn't have to be limited to worldwide. It can go to Mars eventually. So that's this portion. Now let's go see what type of resources are we talking about. We have a pool of resources. And so what resources are we talking about? These are configurable compute resources. Compute resources means what? Exactly, it means things like networks, servers, storage, application, services. So you bring whatever you have in terms of what you already know of as technology resources. When you have a company that has computing infrastructure available, those are resources that company provides to the employees and customers. And in the context of cloud, the idea is companies will share those resources, these things, network, server, storage, application services, and many other things, put them together in a configurable pool and allow users to rapidly provision them and release them with minimal management effort. So that's the idea. Very little effort is needed for any user to provision a resource, meaning provisioning a resource means get access to the storage, for example, or get access to a server, for example. With minimal effort, you can get access to a storage location and also release it when you don't need it. So it's conceptually the idea here is you want something, you get it, you don't want it anymore, you get rid of it. So I'll show you a live example now. Very, very simply, here is the command line. And by the way, this is what I love. And most people hate it to begin with, but eventually you will fall in love with this thing. This thing is called the command line, my favorite tool. And yes, you will see a whole lot of this in our program as we go through. A whole lot of me with the terminal. That's what I do. And so here is the browser. You already know this. I am logged into Amazon. I will go to the Amazon console and maybe log into a different account which will not disturb my production setup. I have something running in this account. I'll probably log into a different account. So let me exit out from here and see if I can log into. Maybe I'll just leave this browser and open a different browser and bring that browser over here, which will be faster for me to just get to the other account. So here is console.aws.amazon.com. There we go. And I think I'm already logged into the other account. So in here, there's pretty much nothing that I can destroy myself accidentally, because I have things running in my Amazon account and I don't want to mess things up. So here is a separate account, separate login that I already have. And here I will demonstrate this concept that I already mentioned, which we are discussing, that PDF file. Where is that? Preview? No. The PDF file is here, right? We are discussing this thing called rapidly provisioning and releasing, for example, a storage resource, right? Let's go to that piece. So how do you do that rapidly? You open a browser, you say that I want some storage. So you go to this thing called S3, and we'll talk about more about S3, but I'm just demonstrating a quick idea here. And I need a place to store stuff, right? So I create a bucket. So here's how the bucket looks like. So you create a bucket, and that is my bucket. Haha. This haha is kind of necessary sometimes, because The word "that is my bucket" may be taken by somebody else. So I'm just adding that haha to basically make it unique. And yeah, I got the "that is my bucket" created. Did I create? No. I have to create the bucket, so I have to go down and hit the create button. So here I go, create button. That's the orange button you see at the bottom. Shows me that I can create a new place to store data. Now I don't have any things to store data. For example, here S3, give me a list of all the storage buckets that I already have in my Amazon account. On the left black window, you see that it will give you empty, nothing. There we go. We got nothing as an answer, like empty answer. Because I don't have any place to store stuff. So I'm going to create a place to store stuff. Here I go, click the button, orange button on the right window, create, and then it created a bucket. The bucket will be called "that is my bucket," haha. And so that bucket now exists in my account, which means I can go to the left side and say, hey, show me a list of my buckets. And so here it shows you "that is my bucket," haha, is the name of the bucket that I just created, and the right side showed up on the left side, because the idea is on the left we are looking at command line interface to the same service which we are interacting with on the right side using a browser. So two methods. Back to here. What I just did, simply provisioned rapidly, conveniently, on demand, whenever I wanted, through my network, access to a storage bucket, S3 bucket. I called it whatever I want, like "this is my bucket," haha. It's the name of the bucket that I wanted, and I got it, and I provisioned it. And see how easy it was, like minimal effort. Another key idea here is minimal service provider interaction. That means I did not have to call Amazon and say, hey, can you please provision a new bucket for me so I can store my data in the bucket. That was not necessary. That's the idea here, is that you want something, you get it. Now, if you don't want something, you can also release it like that. Release, rapidly release with minimal effort and minimal interaction. Like you don't have to create a service ticket with them. You just go here, go to Amazon and say, hey, that bucket, that is my bucket, haha, I want to delete it. And so it says, are you sure you want to delete that bucket? Please type the name of that bucket that you want to delete and say, I did that. This is my bucket, haha, and I delete the bucket. The bucket is gone. Yes, dead. Literally, I relinquished it. What did I do? I released that storage with minimal effort, without having to call Amazon, without having to do anything as such. Now on the left side, let's see, AWS LS S3 LS, show me the list of all the buckets I have, and I get nothing because I deleted it, right? That's the idea. So this is the conceptual demonstration of the concept that I mentioned, which is right here. And that idea is, and by the way, many of you are chatting right now on the website, and I'm seeing those chats. They're welcome. You are absolutely welcome. And what I want to do is make sure that I answer if there is any critical question. Yeah, there are questions apparently. So what I'll do is ask you to, hold on, let me just show it to you. So here we have this thing called Slack, and you probably have access to Slack already. And so here in the Slack channel, you can see the general channel, or you can also do a DM, a one-on-one with me if you like. But in this, you have invitations to join the Slack chat through lots of people already are chatting with Cloud Genius as such, and I will be answering each and every one of those questions there. What I would like to suggest to you is, if you don't yet have an account, please go here to cloudgenius.slack.com or look for an email in your inbox. You will have an email there, and use that to join into this workspace called Cloud Genius Workspace, where you will be able to ask a question, and that question I will personally answer. If you ask that question in any social media chats I should tell you that I will ignore all of those questions because it's impossible for me to answer each and every chat question that comes up in like 7 or 8 different social media channels. It's practically impossible. So don't bother asking questions in the social media channels. If you really want an answer, I will answer them. But please come on Slack. I will answer that. And so that's the best way to answer your questions when you have them. And that Slack is like a 24/7 open. You can just come and chat and whenever you feel like. So it's not that big a deal at all. You can do anytime you feel like. Having said, let's go back here. Oh, that was Slack. Not here. I'll go back to our definition. And so we finished one sentence by now. Let's go see what did we read. We read cloud computing is a model for enabling some kind of easy access to a shared pool of computing resources like storage, network, blah, 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 that you can rapidly provision and release without having to call the company that's giving you the service. So why do these companies do that? Because they want money. So they do give you a service and you pay them money. Yes. It's all about money. Like it's like renting a car. You go and you rent a car. Then you bring that car home or wherever you want to go. But then suppose you bring the car home and then you fill up with stuff and then you go drive somewhere, some national park and come back. And then when you keep the car in the garage for 3 days, do you have to pay for that 3 days that you did not actually use the car? Yes, because you have provisioned the car away from the car company, the rental car company. So you have to release it. If you don't release the rental car, they will keep charging you, gladly charging you every day, and sometimes overage fees because you go beyond the date that you thought you would return, you did not. So they will have fee structure and you will have a contract and you will have your credit card with them and they will be able to charge you. That's a business. That's exactly kind of sort of business this is. Cloud computing is basically a rental business. The renter is Bezos. Jeff, maybe he's not these days, I don't know who he is, but some person appointed by Bezos is the company manager, and he or she, I don't know who that person is, some guy probably, and so that guy is renting his things to you and you're renting them. So it's basically, I used to say that cloud computing from Amazon is like renting Bezos computer, Jeff's computer. I use it, or maybe I use Sundar's computer for Google Cloud, or maybe I use Satya's computer for Microsoft Cloud, and things like that. You're basically rental agreement with them that you rent stuff from them, and stuff can be these things. It's not a rental car, but practically it's the same idea. Same idea. It's somebody else's computer, Satya's computer, or Sundar's, or who this new guy is after Bezos. So those guys, they're renting you. You have to return it to them. Now what's the idea here? If you rent a server from them and you decide that you don't want it anymore, you don't just keep that server running or shut it down and put it in your garage. You have to go back and relinquish it, release it. If you don't release, then the problem is they'll keep charging you. So that is something that you have to understand very carefully. When you don't need some things, you should terminate them. Yeah. The way I describe this idea for people to remember is this. I will be back. And so this guy is what I mean as Terminator. You have to be this guy and kill those servers that you get from any cloud. When you don't need them, you have to kill them, terminate them. Like, just don't ignore this sentence. Termination is super important. So for example, you go to say here and get a server instance running. You can start it, you can stop it, you can also terminate it, and I'll show you an example. So it's pretty soon. You have to terminate it, otherwise the bill will keep accumulating. these guys will keep charging you. Where is the bill? So there is some billing section. The bill should be somewhere in the billing dashboard, and somewhere in here, see, I don't use this account, so I don't have a bill, but somewhere in here you will have slowly accumulating 3 cents every hour for a cheap machine, accumulated charges that go on and build up. You don't want that. So spending is okay, but wasting is bad. So remember to terminate. That is the key idea. To take away is, when you don't need a rental car, don't park it in your garage. Go back to the rental company and give it back to them. That's how you save money. Otherwise, you will be wasting. Wasting is bad, spending is okay, as long as you need it. Okay, that's the idea behind that definition piece that we were discussing here. So let's go to the next sentence. So we just finished one sentence by now, and we'll go to the next sentence. So here it is. The next sentence is this. Here it begins. That's the sentence. So this model composed of 5 essential characteristics. 5 of them, 3 of these, and 4 of something else. Yeah, so 5, 3, 4. We have to understand what these 5, 3, and 4 are. So there are 5 characteristics, 3 service models, and 4 deployment models. And we'll understand each and every one of them. Let's go see the 5 characteristics. And they are here. They're right here. And so let's go focus on these characteristics. And again, this is fairly long reading, so I will focus just, I'll not actually read too much, but I'll just give you the sense of these things so that you get the idea. The key essential characteristics, there are 5 of them. 1, 2, 3, 4, and 5. Let's go understand each and every one of them. First one, on-demand self-service. So this is basically Ariana Grande, 7 Rings. The lyrics are, I want it, I got it. On demand, self-service. I just go, grab it. And you know what? These cloud companies let you grab it because on the back end you have a contract with them. You give them a credit card, and they have a term sheet, a sheet of, what I call a pricing sheet. They'll give you, if you take this thing, then you will be charged that much. Right? Very cheap, dirt cheap. Like really dirt cheap, 2 cents or 1 cent per hour for a machine. It's kind of usable machine. It's a very cheap small machine, but it's kind of sort of usable. Of course, you pay slightly more, like 10 cents, and you get a decent powerful machine. And sometimes these companies give you lots of free stuff. So I have a whole list of things that you can find on the website where you can go and sign up through those links that are basically coupons. Like Amazon gives you a full year of usage for a cheap, tiny T2 micro, T3 micro machine. 1 full year. Why not? Use it. In fact, that's what I would recommend. Probably most of you already have an Amazon account by now, and you have experimented with just setting up the infrastructure needed for the program already. And you are in that process using that free cheapo machine which Amazon is giving you for 1 year since you started working on that cloud. So watch your bill. It'll be free, but keep an eye. This billing dashboard, don't ignore it. This, wherever that billing dashboard is. Yeah, this billing dashboard, you should not ignore it. Keep an eye. It should be 0 for the first year. But if it goes up, that means you are forgetting to do something. What are you forgetting? You are forgetting to terminate the instances or resources that you don't need anymore. Don't forget. It's not a good idea. You will be wasting money. If you don't need something, kill it. On-demand self-service. You got that idea very clearly. That's one of the key characteristics. That means if it is not on demand, so like there are sub companies, many companies that we know have a thing called IT department. Yes. And that IT department behaves like you open a service ticket with them, and then you wait for 10 days and get the manager's approval to get a workstation ready for you to deploy some software that you may want to use for your corporate work. And there'll be back and forth email discussions about whether it should be approved or not, and that is just pathetic. And that is what this thing is not. This is self-service. You don't have to open a ticket, available on demand. So if something is not on demand and not self-service, it is not a cloud. As simple as that. That's what this key characteristic has to be met. So don't think your IT department is giving you a cloud service if they're asking you to open a ticket to do things. Because it is not, it's not a cloud, it's not on demand, it's not self-service. So it defeats the definition. And so that is not a cloud. It has to be on demand, it has to be self-service. Otherwise, you're requiring some human interaction with the service provider. IT department, make a phone call to this number or open a service ticket on the ServiceNow dashboard. It's nonsense. That's not cloud. This is how cloud should be. It's a requirement. It's an essential characteristics. The first characteristic. The second one, it is available on a network. That means you can access to those services through a network, whether it is your internal network in the company or outside the network or outside the company in a public domain, or a variety of other deployment scenarios you can have. But as long as you can access it, that's considered a cloud. It may be limited to only you. It may be limited to a certain group of people within the company, for example, but needs to have some kind of a network-based access. And if that's the case, then that condition is met. Next one is resource pooling. And that is something to really understand very carefully, is that the resources are pooled among multiple consumers in a multi-tenant model. What does that mean? It means if this is a cloud and here is a company called Starbucks, which is a coffee company in the US. Starbucks, they make coffee. And here is another company called Mercury Coffee. It's also a coffee company in Seattle area. It's also in the US. So two coffee companies, both can access the same pool, the same shared resource. And they may be competitors, so Starbucks and this Mercury Coffee, so a small company, for example. But both are coffee companies and they are accessing a shared resource. That's something to understand. So in a different context, you will have something like the cloud and you have some servers. They are shared, and one big company called the Boeing company is using this portion of the shared pool, and another big company called what's it called? The French company, Airbus. Yeah, Airbus. Now that company is accessing the same hardware, partitioned separately. Don't get scared. There is isolation between these resources. That you actually, the portion you get is completely isolated from other people accessing. So don't worry about the security aspects too much, but understand that resources are shared, pooled, and can serve multiple consumers using in a multi-tenant model where different things are shared according to consumer demand. So if you need high security things, you don't want this multi-tenant thing. You want a single tenant model. So you'll ask your service provider, the cloud company, hey, I don't want the boxes that Airbus is using next to my boxes where I'm using if I'm the Boeing company. So give me separate. And since you have money, like a giant company, Boeing, these other giant companies like Amazon or Microsoft will say, yeah, we'll do it for you. Multi-tenant, you don't want, I give you single tenant. They pay me $10 million per month or something like that. And then, yeah, fine. Big companies have no problem doing that. And so they do this. And it's totally okay. But understand that the resources are pooled. And multiple consumers can access in a multi-tenant model. And that's what most public clouds are, multi-tenant. Unless you ask for a specific type. And how do you do that? Even you and I can do it. Even though I'm not a giant company, here's how you do it. So you go and click and say, give me a machine. And by the way, you will get familiar with this interface as you time progresses. So go click get me a Ubuntu machine, and here you can select that I want a decent size, and say C4 large. That's a good size. Yeah. So give me that machine, and then please put me in a tenancy that is not shared. See that button is already available to us, so you can select that I don't want to run a shared hardware where I'm Boeing and Airbus wants the machine right on the same physical box partitioned. If I don't want that, I should come back here and say, give me dedicated instance or dedicated host, where completely the whole physical box that you might have in the cloud company belongs to me, and so you go that way, and additional charges will apply for a dedicated tenancy. And that is something worth paying for if you are worried about security, or really psychologically worried. There is no security issue as such for most practical purposes. And some people have compliance requirements, like the government says Boeing will not do XYZ. Fine, they have no choice but to follow through. And so when that's the case, you better go pay up and get a dedicated tenancy. So that's the underlying idea here. You can choose. Most cloud companies these days provide these kind of options, where your tenancy is defined depending on how much money you have. So if you have more money, you go dedicated. Unless if you don't have a need, don't go, you go shared. But if you have a requirement, some legal requirement or some government mandate that needs to be dedicated, well, then you pony up. Otherwise, this is good enough. For me, yeah, shared tenancy is just fine. I don't operate under a mandate, so I'm not a regulated business as such. In this business, I should clarify. Cloud Genius is not a regulated business, so I can do whatever I want, and I do it already. But there is no mandate on me saying you will do it this way. So I do whatever I want. Basically, what I do is save money, because everything goes straight out of my pocket. So I don't want to waste money, and that's why I'll be back. Terminator. So resource pooling, right? Multiple consumers. So be aware of that. Next one, rapid elasticity. Elasticity is simply that you can stretch, make it bigger, or shrink, grow and shrink. That's the idea behind elasticity. Make it bigger like elastic band, or shrink it down. That's the underlying idea behind this word, elasticity. But what does an elastic have to do with a computer? So let's go discuss that. An elasticity idea. And so the idea goes like this, something like this. So here we have, let's say, one computer, and I need more horsepower, so I can grow this thing, right? How do I grow a machine? Well, I can grow it to be a bigger machine, or if I need even bigger, well, I can grow even bigger. And bigger boxes are available, bigger size computers are available. So that's the idea behind growing in one sense of the word. Small, medium, large. Grow. Large, medium, small. Shrink. That's how you can grow, is one way to grow and shrink. Elasticity idea is one of these ideas is this. When you're growing and shrinking like this concept is typically drawn on a picture. You draw it like this. Small, medium, large. And you can have extra large, extra large, and keep going bigger and bigger if you like. But grow and shrink. It is called vertical scaling. Vertical. This is grow This is shrink. So that's how you can create elasticity in your infrastructure of computers that you might have. Just one example. Growing, shrinking in vertical aspect. There's another way to it. By the way, this becomes very expensive. Actually, I should add more. So it becomes exponentially expensive to get a bigger and bigger box. You can look at the pricing and find out what the price you will be paying if you go vertical scale up. So a cheaper way to accomplish a solution. There are, of course, this is a needed solution for certain scenarios. You have to grow vertically if your application requires that. You have to grow it like this, vertical scaling, and you have to fork money depending on the application you have. There are certain applications where you don't have to grow like this. What you can do is grow another way. You have a box, small size. You need more power, you just get one more box. And like that. You grow horizontally. And when you don't need these boxes, you shrink like that. Shrink. This kind of growing and shrinking is also elastic, and this is called horizontal scaling. Another word for the same idea, horizontal scaling, is called scale out when you grow, and scale in when you shrink. That scale out, scale in is another way to describe horizontal growth and shrinkage. Whereas this picture that I drawn earlier is the vertical scaling, and this grow has another word to describe. This is called scale up, and this shrinking is called scale, of course, down. So up and down, vertical scaling, out and in, horizontal scaling. That's the elasticity idea here. Elasticity. That means you can grow and shrink the infrastructure you're using, provisioned and released. How do you release? Terminator, you kill it. How do you grow? You just ask for more, they give it to you. And so that's the underlying idea. Scale out, scale back in, and also this idea of scale up and scale down. You're also growing and shrinking. In both cases, you're rapidly provisioning and relinquishing or releasing your resources. And that's the underlying concept of elasticity. And if your IT department cannot do it this way, well, they're not a cloud. You have to be able to rapidly grow and shrink. Whether you grow up, or as in scale up or scale down, or whether you scale out or scale back in. Out versus in. This is up versus down. Both are elasticity. They can grow and shrink. Out versus in, up versus down. If you cannot do this way, you are not a cloud. As simple as that. That's the essential characteristic. You have to have it. So we got 1, 2, 3, 4 discussed. That's the fifth one. Measured service. There are two aspects to it. One aspect is about billing. That means if you want a big box, like this box for example, you better pony up all this money. That means the cloud provider has to keep track of how much are you using. They have to measure what are you using and they have to bill you for that. That's measured service. That's one idea. Measurement of usage. How much are you using or using up? And they need to get compensated for that. So they will basically measure what are you using on a, some people do per minute basis, some companies do per hour basis, and depending on what the billing agreement is, they will measure what you are consuming and they will bill you for it and you will pay. There is no escape. If you use it, you pay for it. And so the freebies apply, of course. Most cloud companies give you freebie as you learn. They want you to learn, and so they're giving you free stuff. So take it. Here, in the context of the second idea behind measurement, measured service, is they also help you measure how is your application doing, performance. Is it performing well? Is it not performing well? An example of all this Cloud Genius infrastructure that I have, that I run in, I think they are running in the Google Cloud. So let me show you some quick and dirty view of performance of that. There it is, right here. So some machines are showing me some CPU utilization, like right here in this picture. See, 80% use of something is happening. There are these machines showing up, and it's pretty decently used up, as in consumed 80% on all these three machines together. And I'm not using up all the way to 100, but I'm basically getting the most of my money that I'm spending on these machines in this cloud, because I'm actually not idling them. They are not idling. They are running, they are doing things for me right now. What are they actually doing right now? Let me tell you. What these machines are doing is helping me stream what I am doing in this video conference. Stream it out to here, like right there. That's on my own website. Plus, this stream is also going through multiple different social media, what do they call them? Facebook Live, something like that. Oh, this live, that live, some social media live. So I just send it to everybody. So wherever you are, wherever you happen to be on social media, you will be able to watch it. And then my software actually runs on these boxes and sends that. So that is the measuring aspect which you're looking at here. Measured service. It not only measuring how much I'm using up, so it gets me a bill, but also measures for me how am I using the machines that I have. And I can do measurements of a variety of things. I just showed you just one metric, the CPU consumption metric. There are hundreds of others. The idea here is measured service. So that means if you have a bunch of computers somewhere that cannot measure, well, they are not a cloud. So these are the 5 characteristics that clearly distinguish what is a cloud versus what is not a cloud. That's the takeaway. So 5 characteristics, we got that. Let's go see the other, something else. What are those things? Let's go read, what was that thing called? 3 service models over here. 3 service models. So we discussed these already, and we'll discuss that also. But let's focus here. 3 service models. So what is a service model? And I would like you to tell me if you know examples of these service models, because you probably already use them quite a bit, a whole lot of them. So here are the 3, and I'll just name them. Software as a service, platform as a service, and the third one is infrastructure as a service. So it's down there, so I'm going to scroll it. Here we go. So the third one is infrastructure as a service, like right here. So these 3 words that I mentioned, infrastructure as a service, platform as a service, and software as a service, right? Those are the 3 key service models that I just mentioned. And what I would like to do is ask you on the chat, tell me examples of these things: infrastructure as a service, software as a service, platform as a service. Tell me in chat, whatever you feel like, just chat, type examples of let's begin with software. I think, yeah, let's begin discussing with software as a service. And that would be things that you use today, every day probably. And that is something that I want you to understand. You probably already do. And those things are things that you use are software available to you as a service that you use every single day. An example would be, Gmail. Many people use it. It's basically, Gmail is an example of email as a service. Email software as a service. An example is Gmail. There are tons of other examples like Hotmail and what are the things? Yahoo Mail, Yahoo. And there used to be You Got Mail. I don't know if people know about that. There used to be a thing called You Got Mail. America Online. This was a thing that probably people don't remember. Probably some of them you already have an account like with AOL for some reason. But when I was new in this country, when I did not have money at all, like a poor student 20 years ago, this AOL used to give you CDs like CD-ROM in your home, and they give you free stuff, like free internet for some period of time. So I remember using that AOL quite a bit, like free, because as a poor student with no money, that's what you use. So I used to use that quite a bit, free stuff, AOL, and they used to have this sound called You Got Mail whenever the new email arrives. That was so annoying, but people loved it apparently. So I disable all notifications in my computers and my phones at all. Like there's absolutely no ring notification whatsoever and no email notifications. But people used to enjoy having this notification from a new email, because probably that time email was a novelty apparently. And so, hey, I got an email from somebody nice, as opposed to somebody receiving a postal letter. So yes, email used to be a novelty. Now it is an essential service. And so I just deleted AOL. I shouldn't. Maybe I'll just put them back. They're actually, probably they're still a valid service. Let's go see them. Are they a valid service? AOL.com? Probably they are. Yes. And you can probably log in, and I might have a login there. Who knows? So you already know what I'm talking about. Software as a service. This is one of the examples. I should be more precise. Like here, that AOL page is not that software I'm talking about. Interview with Forbes magazine. No, I'm not doing that. Okay, but what you're looking at, these things. See my email inbox, and I get a bunch of mail, and this is the Gmail interface. See, software as a service. And so, what was that? Oh, I accidentally logged my computer out. Okay, I unlocked it, but here. More examples of software as a service. Let's go see. Something like you probably know already is called Office. This Office is actually a piece of software available from Microsoft. Let's go see what that look like. Word.com. Is there such a thing? No. There's Office.com. Okay, yes. So you see, go to Office.com and you try to sign in, and here you can see that, see if I can log in, probably log in as Cloud Genius. There, autofill and password, sign in, and here you can probably see the Office suite of applications available to you as a service. You might have seen this or you may not. I don't know. So I'm going to show you the simple concept of a Word document. You can create a Word document right in your browser without having to have access to the Word software for free. This thing is free, by the way, from Microsoft. And yes, you can write whatever you feel like whatever you feel like. You can write whatever you want, save the document. And by the way, this thing is a browser window. This is the Microsoft software called Microsoft Word software. You can see help and about. They don't have the about button because this is actually a browser. The help about on top is going to be a Safari browser. It's about Safari. But this software called Microsoft Word is running in the browser window because it actually is running as Microsoft Word software available to you for free from the cloud, from the Microsoft Office 365 cloud. And so here you will see something that you probably recognize. Those of you who have used Microsoft Office in your company probably recognize that when you have a collaborator or another person in your company show up to jointly edit this document, like this for example, and you're editing, reviewing changes and all that, and you have comments about other people, you will see that, say for example, your colleague or co-worker, if they are available online, their presence will show up. What do I mean by that? I mean something like this. So if you see this picture, here you have this person in red color, this person in green color, this person in yellow color. Right? All these colors mean something. Those colors basically indicate their presence, whether they are available, busy, in a meeting, available, busy, do not disturb, be right back, off work, and then my favorite feature, appear away. By the way, this presence idea is my patent. You can look it up. This idea. You can find this patent, which is mine. Yes, only me. That's me. Assigned to Microsoft back in 2007 when I used to work at Microsoft. Is the simple technique of detection of physical presence in management of information. Underlying ideas are in this patent. This idea is one implementation of this idea shows up here, as you can see, and in entire Office suite, when you have coworkers, their status of presence also shows up across the Office 365 suite of applications. And that is another example of software as a service. Yeah, I used to work at Microsoft for a decade. And yes, Lync. And before that, this thing was called Lync. And before that, it was called Office Communicator. Office Communicator was the name of the product that looked like this. And before that, it did not have a name because we were working on it to create one. And that's when I worked on this product that became Office Communicator, that became Lync, that eventually became Skype for Business, and now it is going to be rebranded as, I think already rebranded as Teams from Microsoft Teams. The same underlying concept evolved quite a bit. It's now a multi-billion-dollar product for Microsoft, and Microsoft is $1 trillion, maybe $2 trillion. I don't know what company, but yeah, good product. I don't know what Teams. I have no idea. I'm not worked on Teams as such, but I did work on the original, the one that did not have the name. That product that became Office Communicator. That's when I used to work a long time ago. So this concept of software available to you as a service is software as a service. There are tons of companies that do this thing. Office is one example. Google Apps, they have a new name for it. It's called Google G Suite from Google. And there are many other such companies. We will have an exercise coming up soon at some point where we will be doing Zoho Office Suite. Zoho is an idea that I like for its simple concept that it is actually free stuff. And I like this as an academic exercise. It's not good for production usage for setting up a company. I would not recommend that free stuff. But for learning, great for learning. If you're really setting up a new business and want to have Office Suite for your employees, go with these guys. Google G Suite, like I have. Actually, I have both. G Suite from Google or Microsoft Office. That's what I would recommend that you go if you're setting up a new business. If you're just learning, try Zoho. And we will have an exercise that I'll do with you. We'll have a domain. Don't spend money. Don't waste money. I would recommend you buy a domain for $1. How do you buy that? Only $1, nothing more except taxes maybe in your locality, wherever you are. Depending on which country you are, you would probably have something like this. So GoDaddy, $1 domain, coupon code, search for it, and you will have something like this, 99-cent domain name, and get a cheap domain name for you. They want to sell you a bunch of other stuff alongside with that domain. When you buy the domain, don't buy anything else, only buy one domain by spending 99 cents and taxes for your region in your country, and that's it. Don't spend anything more. That's the only thing I will actually ask you to spend, because this is something you need to control in your own possession. You need to own it. So you should buy this 99 cents. One domain. If you already have a domain name, you don't even need to spend another $1. You just use it. Just use whatever you have. That's the domain. I would recommend that you get one, and then start using it for real with an example service that I would help you set up, like office productivity applications on your domain for real. Like you will have, like I have this, for example, this domain that I have, cloudgenius.app is a domain. It's my domain. I also have this domain called CloudGenius with a dot placed right before the US, and that used to be the old domain name for my company. I still have it. Then what I did is extended that to be like this, like BA Cloud Genius. That was my domain. It still works. The same website you can open up like this, and it still works the same. It basically redirects to this place. So line 14 goes to line 12. So that is a domain, and I have these domains mounted on both Office from Microsoft as well as Google G Suite from Google. And I'd like to tell you that since you are participating in Cloud Genius programs, I can gladly give you access to both of them, number 5, number 6, because Microsoft wants to give all of you access to their service through Cloud Genius. Because you are a student, I have the ability to give it to you. So take it. If you want it, Slack chat with me, I'll enable it for you. Same with Google G Suite. You get full access to Google's services as well as Microsoft Office services because you are a student with Cloud Genius. These are educational offers. These big companies give it to help education. Cloud Genius is an educational institution. So I'm telling you that you have access to those. You can get it. Now just remember that if I decide to not run Cloud Genius for some reason, I don't know, that might happen. Who knows? It has done phenomenally well, and I'm still doing it. But one day I retire as in I already retired 10 years ago, by the way. But if I decide to just chill and go to Himalayas in India and do nothing, It's called sannyas. In in India, it is called sannyas. I'll do nothing, and that probably never happens. And at least not with me. I'll always be doing something. But if that happens, if I go to Himalaya and do nothing at all, then these things will not work for you. Just remember that. So these big companies, Microsoft and Google, are giving it to you. Just remember to follow their terms and conditions and use it. I'll enable it for you. That's the free offers that these companies give to Cloud Genius students. So take it. So these are softwares available to you as a service. One last example. There is a very well-known software as a service. It's called Salesforce.com. This company basically had a logo. Let's go put up the old logo. Salesforce old logo was very interesting. Where is the old logo? Not this logo. There. That used to be the old logo. Right there. This one. Yeah. Software crossed out. What does it mean? It means no software. That's what it means. Software strike. Cut out. No software. What are they really trying to tell you? Is that you don't have to install any software. It's already installed for you. It is running as a service for you in the Salesforce cloud. That's the idea of software as a service. It used to be called, like in year 2000, we used to have this thing called App on Tap. Why is my pen not writing properly? Okay. App on Tap. It used to be called like that in year 1999, 2000, before the dot-com bubble. There used to be some companies like this. There was a company called Coreo, C-O-R-E-O. I don't know if they still exist. They used to be like big on applications on tap, meaning you open a browser, boom, the application is there in the window. That's the underlying idea of this thing called no software. In fact, their phone number is still 1-800-NO-SOFTWARE. That doesn't mean there is no software. All it means is that you don't have to install any software. That's another software available to you as a service, and that was the original idea behind this logo, which is now looks like this. And what do? They help salespeople sell more. They're basically Salesforce company that helps you sell stuff. So if you are a salesperson or a company that is selling stuff, you may want to use their services, and they give you ready-made software that you don't have to install because it's available to you as a service, SaaS, software as a service. So we discussed these, and these are very trivially, easily understood ideas. So I'll not spend any more time on this idea as such, unless you want, in which case you are free to chat with me on Slack. If you want these Microsoft or Google accounts, again, Slack chat. We'll do an exercise at some point, which is to use your domain with Zoho Office, or you can also actually use Microsoft Office in Google Suite. They give you some free stuff. So free stuff is like 15-day trial from these guys. These guys give you 14-day trial or something like that. So you can try it out. It's a full-fledged service, but it runs out. The good thing is that these guys, they have a service that doesn't seem to run out. That's the only distinction between these guys. So free stuff doesn't die after 14 days. You can mess with it. Great for learning, and then you can ignore it after you know what it is. So then you can, when you want to set up your own company, your own business, maybe you go this route, or maybe there are better routes you create for yourself. Like for example, run your own email service. Possible. I used to do that long time ago. I gave up because it's work. I don't want to work, so I gave up. But yeah, I used to run, like, email actually arrives in my home on the SMTP port. The inbound port. I used to send out straight from my home box, SMTP server out, and emails used to come straight to my MX records pointed to my home machines. This is a long time ago. I don't do that anymore. I used to have like a full rack in the garage, basically like my own cloud. I still have that rack, but it is not functional. It's dead, almost dead. There are other things that I have, but that one is gone. It's basically retired. I need to like recycle it or something like that. But software as a service, I think you understand that idea. Now let us talk about this thing, infrastructure as a service, and let us see what it does. So infrastructure as a service is simply what it says, what it means. Give me a second, I'll just grab a drink. Give me a second, I need to also stretch a little bit. It has been like a 1.5 hours almost. So let me stand up and change my orientation on a standing desk. So let me just adjust my desk a little bit. That does it. So I'm going to stand now and keep my chair away. Okay. Okay, we are now going to discuss this thing called infrastructure as a service. So you saw those examples already. Where did I show you? Here. Console dot in the Firefox browser, I think it was here. So you see we are going to get some machine instances up and running. So just a box. You get a computer, right? You want a computer, you get a computer from here. Right now I have no running instances, so I want to launch an instance. You can launch it like that and get a machine up and running. And I will actually demonstrate this idea live so you get a clear concept. What is infrastructure as a service? So let's go understand a couple of things needed for that to happen. And a couple of things. One of the ideas is this idea of this folder called .ssh. That's one component I'll be talking about. The second key idea is this browser interface, which you will be able to use to get a machine. By the way, many of you have done one exercise already, which is to set up the CloudGenius workstation. And that exercise happens completely automated. Like you don't actually do much. All you do is like run some commands. You watch the previous video to this session, you will see that what I'm talking about. If you haven't done it, watch the previous session video. You will see what I do is through automation, create a workstation in the Amazon cloud. And the whole thing is hands off, completely automated, and it just works. That doesn't tell you what is going on under the hood. So today, in our discussion around this topic of infrastructure as a service, what I will do is actually create a machine in Amazon cloud manually, like step by step, to help you understand some of the concepts. In order for us to get a machine up and running in the Amazon cloud, for example, you need a couple of things. What do we need? Let's see. What do we need? So we need a contract with Amazon. That's first thing. So they need to be actually know you. They need to have your credit card. And so a relationship with some cloud company. And this is me. So I give them money. They give me resources, whatever I want. And so that's what I'm getting. This time I'm getting some infrastructure resources. What do I mean by that? Right now, in the context of this discussion, I need a instance. I need a server machine, a server instance. I need that because I'm going to give them money. They're going to give me an instance. Now, getting an instance is kind of useless unless you can actually use it. So to use an instance like this that these guys give you, you need to be able to operate that machine, that instance. I call it machine. Some companies call it instances. Some other companies call it servers. It's a variety of names of the same thing. Some people call it something else. Like, there are some companies that call it Droplet. It's the same thing. Servers, instances, machines, droplets, and another company might come up tomorrow and may call it donkeys. Who knows? It doesn't matter. It's a computer. It's a resource. It's an infrastructure resource. That's what you are getting. That's what I am getting right now. But merely getting something is kind of useless unless you actually can use it, can connect to it, can run things on it, can install software on it, can make it actually useful. For that, you need permissions to access. So, since you gave them a credit card, this company gives you a key. It's called key. It's actually a pair of keys. There are two parts to it. There is a access key and a secret key. These two things, they give it to you because you give them your credit card number. They give you this key pair. It's from the Amazon company, given to you. It's an access component and a secret component. They give it to you. You probably have seen this already in the first previous video that you saw when you set up this whole thing for Cloud Genius Access. That's when you created a key pair. It has two components, access key and secret key, which you probably already know. What you also need is a key pair that you generate and you inject into these things called droplets, machines, instances, servers. Some people call them boxes. Sometimes I use the word boxes. Sometimes I use the word computers. They are all exactly the same thing. Servers, instances, machines, computers, boxes, droplets, donkeys. Who cares? They are computers. You have to create a key pair and inject that public key into the computers, the instances, yourself, or ask Amazon to do it for you. So from Amazon, they gave you a key pair called access key and secret key, two components, access and secret. And this is you. Now what you have to do is give them a credit card, money. In addition to that, you have to generate a key pair which has a public key and a private key. Now this private key you keep private with you. You don't give it. You give the public key to Amazon and say, hey Amazon, take this public and inject into the machines that you will create for me. So these boxes, servers, machines, box, droplets, computers, instances. Yeah, inject the public key right here. Before you even start the machine, inject my public key into the machines before you start it, and then give me access. And now you have this private key that you created with you. You will use that private key to connect to the machine using the private key. So that's the pieces that you need to have. Now let's go experiment with real life example. I already have given them my credit card. I already have a key pair from them that gives me access key and a secret, access and secret. I already have those. What I don't have is I haven't generated my own key pair and my own public and private keys. I keep the private key private and public key I give it to them, so that Amazon or just any cloud company that you want to deal with will inject this public key into the machines that they will start for you before you get access. You can access them. So once you have that public key injected, you can use your private key to connect. So those are the pieces that we are talking about. Now, where do you store? So I mentioned this thing called AWS. Gives you access and secret, and then you have to create some things which I call them private key and a public key. You have to create them yourself. You create. And this private key is typically labeled ID underscore RSA. And this public key is typically labeled ID underscore RSA dot PUB. And these files are stored in a folder ~/.ssh in the terminal. That's where you store it. So that's the detail I will now show you here. Here in this location, in the terminal, you can use any terminal. You can even use the Cloud Genius terminal that you have access through the Amazon Cloud that we set up in the previous session. This folder location is where these files mentioned on the right side, line number 9 and line number 10. These two files, 1 and 2, need to be created in this folder here. How do you create them? Well, what these things are, they are called RSA key pair. So, how do you generate them? If you don't know, what do? You Google, right? How to generate a RSA key pair. So the answer will be coming up. So that's the answer. What you do is you run SSH keygen, and then enter, and you will have a public and a private key pair created. That's what is described in this Google search. So you go Google, it gives you Oracle website. Okay, so they show you how to generate a public key pair. That this is how you do it. So that's what I'm going to run, and then that's what happens after that. It generates a key pair by the name ID underscore RSA and ID underscore RSA.pub in the John Doe folder. Okay, doesn't matter what folder, but the key is this .ssh is a convention. That's what conventionally people store private keys and public keys. So I need to run this command for this example illustration that will generate these two files here. These two files, line number 9 and 10, public and private key, private and public key. So, by the way, I already have run it. It's just a question of enter, and another enter. I think there are 4. Just enter. It will create one for you. I already have done it. That's why you see that I have ID RSA and ID RSA.pub. Those two files are already available to me. This is line number 9, private key, right here. This private key is this file, and this public key is this file. It gets generated when I run this command in my terminal. And these files are stored in a folder called .ssh in your folder called tilde. This tilde is an indication of your home location. Home, also known as $home. And that home location is unique to you. It has your name and your computer details. So that's, you define where your home is. Inside your home, which is also known as the tilde location, slash means go inside, and then the .ssh folder is where you store these two keys. It automatically goes there, by the way. So in case you're wondering where it went, that's where it goes. So you have these two keys now, and what I need to do now is get that public key and give it to my cloud company. And so these guys, if you have to call Bezos now, Jeff Bezos, hey, I have my public key for you, please take it. So here I go, cat my public key. This is how it looks like. And by the way, public key is supposed to be public, so you can give it to anybody. I can even show it to you, which like I just did. You looking at it, right? The whole world is looking at it. It's okay. You can show your public key to everybody on the planet. But remember, the private key, this key here, you never, ever, ever share it. Not even with your manager in your company. You don't share that private key with anybody at all. Like, absolutely not. That's supposed to be your private key. You don't expose that file content. Like, don't cat it. Don't show it to anybody. That's private information only for your eyes. And that's it. So you never share it. Public, you can. And then you copy this public key and give it to Bezos. I mean his deputy, whoever that is. Who is that guy? Let's go find out. AWS CEO. Who are you? Adam? When did this guy come up? I thought there was some other guy. Oh, Andy. So the thing he got promoted. So okay, Andy is the CEO of Amazon. This Adam is the CEO of. Okay, so Adam. So I'm going to call Adam now. I mean, I'm just kidding. But hey, Adam, take my public key. Like that. And give it to him. So what Adam will do is, whenever I order a new machine, he'll take the public key, inject into the machine, and hey, Dilesh, your machine at your service. So I can access it whenever I feel like. And that's my plan. So what I'm going to do is make a phone call to Adam. This is how you do it. You go to EC2 and you look for key pairs. Right? But before you do any of that, you remember that you have to select a region of choice. I think you remember that from previous session. You remember that you have to select Oregon for ease of use. So everybody uses Oregon when you're first time trying. Most of my examples and exercises that you will see in my website, which you will see when you log in, are based on, if you're using Amazon Cloud, they're typically written for the Oregon region. So you need to remember that my exercises will not work if you don't select the right region. So that means you have to go here, and for some reason Amazon is these days giving everybody this region as the preferred default choice. Whatever. When I signed up for Amazon 14 years ago, they used to give this Oregon as the default choice. Ohio didn't even exist. I think they used to, before that, I think they used to give this Virginia as the default choice, but I chose this as my default. I think whenever I log in, I still get the US East one as the default choice. But remember, this is what our exercises are designed to work with. If you want to change something, you can. Just remember to modify the exercise and do whatever you want. Go to Seoul or Mumbai or wherever you want and work with. Just make sure to change the region. That's it. By default, we go Oregon. So I will go to Oregon. That means I will select Oregon like this. And then it shows up right here. Once you make sure, then you go to the services section and EC2 and services EC2 and then key pairs, and you find that I have nothing, no key pair to display. So I'll now call Adam and say, hey Adam, take my public key, like right there. See my public key here. I want to read it out to him like letter by letter. Like copy this, make a phone call, read out this whole thing to him, and he will diligently just kidding. So what needs to happen is you need to grab this action, import key pair action. So see, there's a create key pair action also. Don't do that. My methods typically are my own methods. So I don't like to use that create key pair method. I'll tell you why later on. Right now my method is to choose my own key pair using my own computer, like right there. I go to my computer, create SSH keygen, and create my public and private key, and then copy my public key here, and then import into Amazon, import into DigitalOcean, import into Google Cloud, import into Amazon, Microsoft, some other cloud, who knows. But that's what I like to do. So here I'm going to call it ID_RSA, and then paste. That's how you tell them that, hey, this is my key, public key, and I want you to import it. So I import the key pair. So now it imported the key pair, and I show it there. RSA key pair, ID_RSA, the fingerprint and all that good stuff shows up. Nice. So I successfully called this guy and gave him my public key, like that. So easy. Don't even actually have to call them. Now, a couple of details. This key that you're looking at, public key, if you go zoom into it, you will find that this thing has a beginning line. By the way, the whole thing is just one line. It's just one line. I just want you to know it's just one line, line number 1. That's it. There's no second line here. So all of it is just one line. It's a very long line, that's why it's wrapped around. It begins with SSH-RSA, then there is a space here, and then typically AAA something all the way to this point. Equal. Followed by your identifier. It can be any comment you want. So this is, iMac home, my domain. This is the machines that I have in my home for my company. So my company is my home and my home is my company. I don't know what that means, but basically that's a domain name for this machine that I'm using. And this is my login name. And that's just an identifier for this public key. That means this is technically not a required part. It can be a part of the key, but it's not a required part of the key. The key that is really strictly required is only up to here, beginning from here, and that's it. This part is optional and comment. Okay, that's understood. So we have the public key given to Adam, and now here, see, I told you I need to create a key pair and I give it to them, so I gave it to them. So here is me creating a key pair like this guy, and then I created my key pair. I don't know why it's not writing, but you got the point. I got the key pair created, I gave the public key to Amazon, and now I'm ready to start the machine. I'll quit this software so it will start behaving properly. Let me just quickly look at my pen as to what's going on there. Yeah, it's working again. Nice. So the next point is we've given the public key to them. Now we can use that public key to start and access and control our computer from Amazon on rent. It's a rental, right? Rental agreement. So now let's go to the console home, go to the EC2 section. EC2 stands for Elastic Compute Cloud, ECC, Elastic, everything is elastic about Amazon. They like the word elastic for branding. And so nothing is plastic. Plastic will break. Elastic will extend, grow and shrink. So EC2, and here we go to the dashboard and say launch one instance for me. And I love using Ubuntu, and so I will use that Ubuntu OS, which is right there. This is 1804. There's a 2004 available. We'll use the 2004 long-term support version, and I'll go all the way to the end and select 64-bit x86, select. Then I will choose the machine size, how big the machine I want. I recommend that you go with the T2 micro, T3 micro cheap machines that are actually for free. So T3 micro is free for you. It is not free for me, but it is absolutely free for you. If you're using the trial, they'll give it to you for free. Use the free one, T3 micro. Then I go to configure the details, and here most of the default settings are correct. Don't have to mess around. We discussed this idea already ahead of time, which was about tenancy. I'm going to choose the shared tenancy. You don't need to spend extra money for dedicated, so I stick with that. Then I add some storage. I add 8 GB of SSD, right there, 8 GB SSD, and then I review the details, and it tells me that you improve your instance's security. Your security group is open to the world. So we'll talk about security at length, okay, and depth at a later date. Right now it's open, meaning anybody can connect or attempt to connect. It will not succeed. They need to have the private key, but anybody can attempt to connect, which is for right now okay. I know it is open, that's okay, but for right now we are leaving it open to the world. So anybody who has the private key can connect to this machine once it gets ready, but nobody has it, only I have it, so I'm not worried too much about it. But there's a cautionary note here from Amazon saying your group is open to the world. I said, fine, I know and understand. Fine. Next one. Your instance configuration is not eligible for the free tier usage. And that's okay with me. I don't even have free tier. So that's okay also. So I'm going to ignore both of them. Next, we'll see the details. It is going to be 1.2.20.04. The instance type is T3 micro. There are 2 CPUs, elastic block storage available, network connectivity available. Then there is this thing called security group, which is allowing SSH connection on port number 22 from anywhere on the internet. Anybody who has access to the private key that I have, that only I have, by the way, because I never share my private key with anybody, only I can actually succeed in connecting, even though anybody can attempt to connect, because the ports are open from anywhere on the internet. This 0.0.0.0/0, this thing basically means open to the world, the World Wide Web, IPv4 addressing scheme, open to the entire internet. And then there are some instance details. This storage, we added 8 GB SSD to this machine, and now we can launch the machine. So I'm going to hit the blue button and say launch, but then it asks you, hey, how will you connect? Well, I told them already, I gave you public key. Just use that public key that I have. I gave it to you already. Use my existing key pair, like that one, and I acknowledge that I have the corresponding private key pair with me, like sitting right there in this folder. That is the file. So I have it already. So I'm going to acknowledge that I know what I'm doing. I have the private key, you got the public key. Take the public key, inject it in the machine, and start it. So it's starting up. Awesome. The machine gets started pretty soon, takes a minute. So we'll go see in our dashboard, in EC2 section, we'll see that the dashboard is showing you one running instance right there, one. We have given them our key pair, public key. There is a security group that I created for our own usage, which is open to the world outside. There is one instance and one of them is running, and that is good. So let's go see what that running instance looks like, and we'll go and hit that button, and it tells us that it is initializing. So while we are here, we'll give it some name. I'll call this computer. I'll call this, what do I want to call it? What do I want to call it? Basically, this name is useless. It's only for humans. What do I want to call it? That's the name. This is the ID, the instance ID, which is how the Amazon Cloud refers to this machine. It is currently running on this IP address. Right? So I'll copy the IP address. It has a private IP address also. It has some other details. We'll see what those details are. So you see that it has this machine ID, machine image ID, which is the operating system identifier for who manufactured that machine image. It's the Ubuntu Canonical Company, the makers of Ubuntu operating system. That machine is up and running, as we already saw up there. And here our key pair is showing up. In here you will see that our security groups, we'll go and check that first. Next, in security section, it will show us that it has access allowed from anywhere on the internet. Anybody can come and attempt to connect on port number 22 through the SSH protocol and try to get access to this machine, provided they have a private key that only I have. So what I will do now is attempt to connect to this machine right now. How does it work? I'll use the SSH protocol to get this public IP address copied and then construct a command. The command to construct that I want to construct is to connect to that machine out there on this IP address. I want to connect to that machine, so I'll say SSH username of the machine at IP address of that machine, and then I need to pass the private key reference. This is how the command looks like, line number 11. So now we need to find out the IP address. So we already know the IP address is right there. Now the @ symbol is important. So you need to pay attention to this @ symbol. And then we need to find out what's the username of the machine out there. It's an Ubuntu machine. And so I don't know. I didn't even tell anybody what the name should be. At least Amazon doesn't ask you for the name of the user on that machine, so you don't even know what the username is. So what do? Well, when you don't know anything, what you do is Google search or any other search except Bing, which doesn't work. Yes, it sucks. If you want to waste your time as a Microsoft employee, you go Bing, because you are showing loyalty to the company and you're wasting your time. If you really want to get work done as a Microsoft employee, you go Google. And yes, I've said that to the CEO and he agreed. Yeah, that's how it is. So Google search. What is the username of, by the way, I already know the answer. I'm just showing you how to get things done when you get stuck. You probably know this. Google search. If you construct how to create a query on Google, that's the key skill to have these days. You know, older days when I was younger, people used to talk about, you need to know everything. Yeah. These days, that is not a skill. The skill that is necessary today is to find what you need when you need it quickly. It's the ability to discover and find is more important than having the knowledge stored in your brain. Having the knowledge stored in your brain is like using your head as a storage disk, like a disk drive, SSD. It's most inefficient usage of your brain. Your brain is a CPU, not a hard disk. So don't use it for storage. So therefore, don't memorize anything whatsoever. Ever. Never. It's useless. Instead, sharpen your brain to find what you need exactly when you need it, the most efficient way. I think that works all the time, and that's how the world has evolved. You know that already, Valerie. I'm just telling you that don't memorize stuff. So, what's the username of an Ubuntu instance in AWS cloud? Answer is Ubuntu. By the way, this answer they gave it wrong because my query was incorrect. This actually is a partially right answer. This is the right answer, by the way. EC2 user is the right answer for any other operating system, but I think it's a Google mistake. Let's go see the problem here. The answer is actually correct, it's right there, but the Google's presentation has an issue here. So let's go see what I'm talking about. Let's go zoom in. It tells you the answer right there. It tells you that for an Ubuntu machine, the username is Ubuntu. For anything else, it is this. And for Bitnami machine image, the username is Bitnami. So we care about this part, not that. Almost any operating system that you find on Amazon has a user called EC2-user. Except Ubuntu, the username is Ubuntu. And in Bitnami, username is Bitnami. So that is the right answer. The top level summary answer was wrong. And I think that is a Google problem. They have the data already right there. They should have read the question being asked and answered it appropriately, and they didn't. Dumb Google. And that's okay. You can call them dumb. They're actually useful. You just have to read properly. So that's where the result, the search was accurate. The representation was not. The result, the search was okay. So we have the username. So now that we have it, we are going to use that username right here. And then we should be able to successfully connect. So we'll go to erase the space here, erase the space here, and then copy this whole line number 11 and take it to our terminal, and then what? Then run it. That's it, like that. So it asks you this question. It says, this key is not known by any other names. Fine. Are you sure you want to continue connecting to this random machine that you're trying to? Do you know what you're doing? That's the real question SSH is asking me. Hey Nilesh, are you sure you know what you're doing? My answer to that is yes, I know what I'm doing, so I'll say yes. And then it just connects to that Ubuntu machine. You can see that the machine I am connected to is actually Ubuntu. And here you can also find that the private IP address matches up. Where does it match? Right there. I started Ubuntu 20. And I got connected by the command line I used. And so I am able to do whatever I want on that machine because I have access and I have privilege, because I'm renting and I'm paying. So I can do whatever I want on this machine. So bottom line, back to what we were discussing, is infrastructure as a service. So what you just saw is an example of a company renting you infrastructure on demand. Back to our PDF file. Where is that PDF file with definition? Here? No, here? Yeah, there. So infrastructure as a service is what we got, is to provision processing storage, network, or other fundamental computing resource like a machine, which is basically processing and storage and network. So that's what we got. From where I am, I'm able to deploy and run arbitrary software, like absolutely arbitrary software. And then some people joked on this Slack chat about running arbitrary software, and I will actually like to run arbitrary software right here. For example, here, sudo rm-rf /bin/laden. Yes, it's totally arbitrary, it's kind of useless and pointless, but it's a joke. So here I go hit it, and I killed Bin Laden. By the way, the day Bin Laden was killed, this was my tweet. Sudo rm-rf /bin/laden. That file doesn't exist, so it's no problem. That Laden file doesn't exist in a Linux machine, and so it's basically harmless. So you can do whatever you want. So that's what I described here. The ability to run arbitrary software. I just ran arbitrary software. I am able to do whatever I want, and which includes operating systems and applications. I can shoot myself in the foot if I want to, because that's arbitrary. So how do you shoot yourself in the foot? You can. I'll let you shoot yourself in the foot. So it's risk-free, because this is a rental, right? You can take a rental car, and as long as you have insurance, you can just hit a big object like a stone or something, and your car is destroyed. But it's okay. You have insurance. So by the way, that's the scenario here. You don't have to worry. You can just destroy the machine, and Adam will not complain. All he'll do is, oh, you killed my machine. And yeah, he said, yes, I did. And so you just terminate the machine, and he stops charging you, and you're back in business, do whatever you want. So that's the underlying idea here. Infrastructure as a service lets you rent infrastructure on demand and do whatever the heck you want, literally. And that is my preferred mode of using cloud services, because I want to do whatever the heck I want. So I actually rent infrastructure from many companies, and I use them, and I customize it exactly the way I want. And I build my own platform, build my own things, build my streaming setup, my website, bunch of other things, all handmade, right here in my office, in my home. Yes, this is my home, by the way, if you haven't seen. I run it from my home. I have some help from India that help me with things that I don't want to do because I'm lazy. And yes, software developers are lazy by definition, so they go to the extremes of writing code to make things automated so that they can afford to become lazy. That's the goal. At least that's my goal, is to be lazy. So I work hard, really hard, so I can be lazy. And that's the whole program all about. Because how can you be, not kidding, seriously, how can you get things done without having to do it? Because you already work so hard in automating everything you want to get done, so you can be lazy. And that's how I say it. But essentially, it's about automation, getting things done, running your business on your own terms, without depending on big brothers, like big giant companies and who dictate. Don't have to do that. You control what you want. And if you know what you're doing, you can get it done. That's the idea. So now back here. We don't manage or control the underlying cloud infrastructure, but we do control the operating system, the storage, the deployed applications, and networking and firewall and other things. You saw me describe these things a little bit in the example I just showed you. So that's the underlying concept of renting infrastructure available to you as a service. Infrastructure as a service. And now the third idea, which is platform as a service. And I think we need a short break. So I'll take a short break, or short timer. a few minutes and I'll be back continuing what I'm doing, because I think a break is necessary. I've been talking for like quite some time now. So let me start a timer on a break, and here we go. Timer 7 minutes, and that's a 7-minute timer. It started already. You can see the timer right on the screen right here, and I will be back. Yes, I'll be back. Okay, so we have timed out of the timer. I'll be resuming now, and let us continue the other idea, which is platform as a service. So I am already streaming live. We just took a short break. I'm back from the break, making sure that you can still see me properly. My video should be functioning. You should be able to see my desktop, and I will answer the chat questions later on. I'm not answering them right now. I am going to just let you know that I got the questions. Awesome. So let's clear out and okay, let's go. So the next idea is platform as a service. So we discussed that. That requires a little bit of separate discussion to understand what is a platform. And so here you can see the definition. It's very vague, very vague. And so yeah, we call it the standard, and it sucks. It's a horribly written document, but it's a standard. So what do we do with the standard which is horribly written? I'll give you the honest answer. The honest answer is ignore it. It's pretty useless. It's academic in nature, right? Yeah, yes, it is the standard. It is established. It's a government body. There are experts have come together to write this. But I'm telling you to ignore it. It doesn't matter. What matters really is to get things done for your customers, for yourself, for your business, for your family. Yes, that's what matters. Anything else is nonsense. But don't bother. The specifications and documents and this and that. Who cares? All that really matters is you're helping somebody else and making them satisfied. That's all. That's what really you should focus on. Everything else on the planet is pretty darn useless. Helping somebody, getting their problem solved, beautiful. That's all that matters. We can read these documents and discuss and debate whether software is something is a platform or not. Yeah, I don't care. But let's go read. Just for the sake of completion, I'm going to read this platform as a service thingy. So the blah 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 whatever. So this is utterly useless definition of platform as a service. So let me give you my own interpretation of what they're trying to tell you. So here it goes. Notability. So I'm going to write down on a piece of paper. It's opening up. There it is. Okay, so here's my pen. I hope it works. Yes, it does. And so now let's go understand what exactly is a platform. Like, what do you mean by platform? Simply, a platform is something you put things on top of something else. This thing, you put it on top of a platform. That's literally what a platform basically means. You already know that. I take a thing, put it on the platform. So anything that you put on top of something, the underlying thing becomes the platform. That's the fundamental concept of a platform. Now, how does it come to play in case of software or computers? So let's go see that. So see, you have some software that needs to run somewhere, right? So you need to have some operating system. That operating system needs to run on some computer hardware, like CPU, memory, disk, network, bunch of other things that constitutes together what I call hardware. So that's what you need. So the operating system needs the hardware platform to run. So this is your Mac OS Monterey. It's the operating system running on this hardware. Which hardware? This M1 Mac, M1 chip, Apple M1 chip, 16 GB memory. It's a Mac Mini 2020. So pretty decent CPU there. You have display. There are two displays. The two displays that you have, one I'm looking at, one I'm writing on. So there are two displays right here. This one I write on, this display I write on the screen, and the other display I look at it. So there are two displays. Apart from that, in this hardware, you also have, what do you have? Let's go see. In the hardware, you have some storage. So I have 2 terabytes of storage, and I have support from Apple and some resources and all that. So the bottom line is it also has some memory and some CPU and some storage available, and of course network. So that's the hardware platform underneath, on which I have this operating system called Monterey. And on top of that, I'm running this software that I'm using right now to write on. It's called Notability. It's an app from the Mac App Store that runs on this platform called Monterey OS. That runs on the platform called the hardware from Apple, Mac Mini in this case, right? And so that's what you need to think about. When you put one thing on top of the other, the underlying thing becomes the platform. So now you take this to the discussion around software as a service. So now if you have some software as a service, let's call it the Salesforce.com software as a service. These guys give you some software that lets you run the Salesforce software. There is a company called Microsoft that gets you the Office software. So you can use Word, PowerPoint, and Excel. There is a company called Google. Google gives you basically clones of what Microsoft Office does. So the clones are, they call it Google Docs and Google Sheet and Google God knows what, Present, Power, Sheet, Slide, something. So basically the clones of Word, Excel, PowerPoint, they have clones that they also provide, and they have a bunch of other software, and they basically compete with Microsoft to create those pieces of software. So these companies need to run their software not on your computer. It runs away from you. It's a service. It shows up in the browser. It's not running on your laptop or desktop. So they need some machines to run that thing. So they run it on custom built platform. This platform, for example, the Office platform or the Google platform, they have their own custom built piece of software that they provide to the developers of these things, that makes it easy for the developers of Office to write Office applications, that it becomes easy for them to write. And under that platform, of course, is an operating system, and under that is your hardware stack. So now let's go see this example idea in slightly more detail, starting from the bottom. The real bottom, what do you have? Is silicon. Now who makes it? Apple. M1 chip. Today is the best chip, I think. Intel makes their whatever Xeon, Core i7, Core i9, whatever chips. Then there is AMD that also makes chips. There are other companies that make chips. For example, those, what do you call them? Raspberry Pi. What do you call the architecture? It's ARM, ARM. That's a consortium of companies. ARM architecture. These are Intel architecture or x86 64 architecture. M1 chip happens to be an ARM architecture chip, and that's the underlying silicon manufacturers. So let's go one level above silicon. What do you do when you have this Intel CPU, for example, in your hand? You need a motherboard, you need some memory, you need some SSD, you need some networking, you need a full hardware stack. So what do you do with an Intel CPU? You go to companies like ASUS, ASUS, or Compal, or Quanta. These are companies Quanta, and Flextronics, and there are a bunch of other companies like that. Flextronics, like that, they exist mostly in Taiwan. These days they're spreading out to other regions away from that region, and these guys make motherboards and the related silicon that other people also provide. For example, there is a company called NVIDIA that gives you the graphics card capabilities, and AMD also has the ATI graphics capabilities, and Apple Silicon has built-in graphics into it, and things like that. So you have to construct the underlying hardware platform. So these companies in Taiwan and other regions, these guys make giant hardware racks that look like something like this. You may have seen it if you work for a large company. That's how it looks like. Yeah, that's a good one. 1% of Googlers get to visit a data center. So this is how it looks like in real life. You know, giant racks and racks and racks of hardware sitting next to each other, connected, wired up through networking gear, switches, routers, and floors and floors of such, multiple floors in multiple buildings, and many such regions containing such buildings is what the reality of cloud is. You have such things out there in the Oregon region, for example, and other regions. So this is how it typically looks like in a data center. If you configure it to operate like a cloud with all the 5 characteristics, that becomes a cloud. Otherwise, it's just a data center. If you don't meet the definition, it's not really a cloud. It has to meet the definition. But this is how typically a large-scale data center hardware infrastructure looks like. So these companies will make that hardware and rent it out, or sometimes they just sell it to people who will take that hardware and put them together in buildings. And these building providers will have cooling, sometimes heating, sometimes networking, connectivity, upkeep, maintenance, electricity. All of that is needed for these computers to run. And then on top you need some kind of an operating system ultimately. But that operating system will not run directly on these machines, because what you want to be able to do is to be able to carve out a portion of that big giant machine to make it a small machine, like I mentioned, this T2 micro size machine. It's a really small fraction of this big machine that you're looking at in this picture. It's a fraction, maybe this tiny fraction. Oops, where did it go? So yeah, here, this portion will be a T2 micro. If you want a bigger machine, like a M1, M5 large, it will be this machine, like that. So they carve out portions of this big giant computer and segregate into smaller partitions. You can call it partitions, and create individual machines right there. And on these machines you will install an operating system, like I did the Ubuntu operating system. Ubuntu is my favorite. It is open source, and that I installed on a T2 micro machine somewhere in some Amazon cloud in Oregon region. I don't know which exact building. I don't even know. Nobody actually knows except a handful of employees. Even in Amazon will not know exactly which building has which T2 micro for which customer. They have no idea. They have it somewhere, an idea, but somewhere in Oregon they will have such buildings containing large sets of machines, and that's how the underlying cloud is constructed. Now, having seen that picture, let's go back here, and for this operating system to run on a T2 micro size machine, you need a way to partition these giant computers manufactured by these silicon manufacturers into smaller pieces. So you take a big computer and make a small out of it. How do you do that? Well, you have a big computer with 64 GB of memory, and you want to create a small computer. What do? Divide, and divide, and divide, and keep dividing until the smallest unit that you can get is still usable. So a usable machine can have something like 256 MB of RAM. It's kind of sort of barely usable machine. You can run a Ubuntu operating system on that tiny fraction of the overall memory on this giant machine. You can run it like that. It's still usable. So you keep dividing a resource that is a big resource into smaller fractions, smaller partitions, until the small fraction is still usable, and you call this T2 micro, for example. This machine will be my M5 large. This machine will be C7 extra large, or something like that. And that's how you design the underlying hardware sizing. And this creation of partitions from a physical box into smaller logical boxes is called virtualization. And we will have exercises on this also later on. But that virtualization is what you need to have as a feature or a function, which is enabled through a piece of software called hypervisor. Hypervisors, there are many. The most popular hypervisor is called KVM. It's an open source software. Every cloud uses this, except Amazon uses Zen hypervisor. Except Microsoft uses their own private, non-open source called Hyper-V. And there are more. There are some commercial. This is a commercial thing. This is open source. This is open source. So I don't care about commercial. I just told you already. I don't care about any commercial software. Only open source. So Zen is awesome. KVM is awesome. I prefer this. This is what Amazon uses. They're also good. But these software that need to run straight up on the hardware, that allows you this feature function called virtualization, that lets you create small but still usable fragments, fractions, partitions of a big giant rack like this. And that's the underlying concept. Now we'll go back to here. You have the silicon layer, the underlying machines created out of using the silicon. You have building, cooling, network, keeping electricity and all that. And then you put the hypervisor. And on top of this hypervisor, it gives you the ability to partition a physical machine into smaller fractions that are still usable, like T2 micro or M5 large or any other size you can see on Amazon or any other cloud. And so on top of this hypervisor, you will have small, still usable fractional computers. And on that you run an operating system. And on that operating system, you then write your own software that makes the job of your software developers easy. To make the life of the software developer easy, you need to create another software from another set of developers. Let's call them the platform software. And these are different kind of developers that will develop software to make the job of these developers easy. So that's the idea. So now you look at the entire picture, all from the silicon point of view all the way to the top. Now let's go recap the whole thing. At the bottom, silicon. Then we have, physical boxes. Let's call them box vendors. We have buildings that will put these things together. Then on those buildings we will have racks. We will have hypervisor layer. That's a piece of software like Zen or KVM hypervisor that will partition these physical boxes that you have under the hood into small boxes, medium boxes, big boxes. And then these are virtual boxes. They're not real. They're not physical computers. This T2 micro that I connected to is not a real computer. It's a virtual computer. It functions just like one, but you cannot hold it in your hand. Even if you go to that building, you cannot grab one T2 Micro and put it in my hand. Cannot do that. It's not possible. It is virtual infrastructure. It pretty much behaves like a real computer, but it is not physical. It is real. It's not physical. You cannot hold something in your hand. It's like, can you hold Word document in your hand? No, you cannot. It's software. Can you hold this Notability software in your hand? No, it is software. And that's exactly what this T2 Micro machine is. It's basically a piece of software that runs on top of, that is enabled through this hypervisor. And now on that virtual machine, you install that operating system that you want. And all of these, if you look at the supply, these guys sell their things to these guys. These guys, give it to these guys. These guys give it to the virtual machine. Sorry. So let's go see the money flow. Let's go look at the money flow. So there is the software developer. There is platform. There is platform developer. There are infrastructure. There are infrastructure developers. And then there are underlying, hardware. There are hardware developers. There are silicon manufacturers who manufacture silicon. So what do? They give silicon to the hardware manufacturers and they get paid in money. These hardware manufacturers give their hardware infrastructure to the infrastructure as a service people, and they get paid in money. Now these infrastructure as a service people will provide their services to the platform developers and get paid in money. Now these platform developers provide their platform as a service to the software developers and get paid in money. So the money flows down, the services flow up. That's the flow. So this oxymoron called platform is basically another piece of software that makes it easy for the software developers to write their software. So what happens typically is a company like Microsoft or Google or any big company, even small ones, what they do is they identify what will it make for these people, the life of these people easier, so that they don't have to deal with all this nonsense under the hood, to make it easy for them. So that's where they will focus their time, energy and effort in building a new platform to make their life easy. See, I told you software developers are lazy because they want to be lazy, and that's the whole idea, because they work hard to be lazy. And so what ultimately you do is you make this software and you sell it to consumers, and consumers pay you money. So the money keeps flowing down all the way to the bottom, and services keep flowing up, and that's where this platform as a service comes into play. So now this platform can be anything and everything that a company needs to make the life of a software developer easy. So that's the essence of this idea here. Where is that? Here. So now let's go try to read what they're trying to say. It's very, let's go read whatever that language is. It says the capability provided by the consumer is to deploy onto the cloud infrastructure consumer created or acquired applications using the programming languages, libraries, services, tools supported by the blah blah provider. The consumer does not manage. Okay, nonsense. Read it yourself. I'm not going to read this. But I already told you what the essence of it is. Like right here, is to provide services up in the chain towards consumers, and consumers pay the money down towards you, all the way to the bottom. This is the economy. This is how economy flows. You give services, you get paid. That's the whole idea behind these three service models: infrastructure as a service, platform as a service, and software available as a service to consumers. That's how I interpret this thing. I know the language is for you to read, especially when you are like feeling, sleepless, that's when you should open that PDF and read it. So you get quickly fall asleep. By the way, I have read it once and it's pathetic. You're welcome to read it. You have it, it's public domain. You can just go search NIST definition. But honestly, don't worry. It is academic. And academic, by that I mean useless. When you don't have a practical application of something that you can actually put for good use to help somebody else, yeah, it's academic. In other words, useless. Yeah. I'm supposed to be a teacher, right? Yeah, I'm also useless. Whatever. That's how it goes. So I run a school. Cloud Genius is an institution, educational institution, and I don't have a title. My title is Dude. That's it. That's my title. So yes, I teach, but I teach hands-on, and I cut all the nonsense that comes with academia. Yes, you must have seen professors in colleges. I hate them myself. I have 3 degrees. Yeah, best of colleges you can think of. World's best. Top-notch universities. Lousy professors. They don't know what you're talking about. They cannot show you. If you cannot show and cannot get things done, you're useless. You're academic. That's how I think. You may disagree or you may agree. It's your choice. But I'm just going to tell you what I think, because that's what you're here for, apparently. So you listen to what I say, and if you don't agree, that's fine. I'll still say. Having said, let's go to the definition again, and the last few pieces, almost finishing up. So where is that PDF file again? There. No. PDF, please. Here. File. There. And bring it down. The last piece that where did it go? There we go. Yes. The last piece that we are discussing here in the definition, which is also a critical component to finish it off, is the 4 deployment models. And with this discussion, I will conclude the session today, by the way. So I'll not keep you long. And we are recording the whole thing. You will have access to the video recording at the end of the session. It becomes available through the website. If you're on Slack, you can see where it is located. You need to log in to be able to see the replay. And there are other things go along in the website that you can actually access. But right now, I will focus my attention on the 4 deployment models. And it's fairly easy to discuss these ideas. So let's go see those 4 models. They are right here. And I'll discuss them in an order that is not listed. So I'll discuss private cloud first, then I will discuss public cloud, then I will discuss hybrid cloud, and then I will discuss community cloud. Or maybe I switch. I'll make this number 1 and this number 2. Yeah. So public cloud. Public cloud is something that anybody, a member of the public, can get access to, provided they pay. So you enter a contract with a public cloud company like Amazon, Google, Microsoft. You pay them. You're a member of the public. So yeah, use it. Public cloud. You saw an example of Amazon in live example exercises already. That's a public cloud. But what about private cloud? So if you're a member of a private group, like employees of a company, for example, it's a small group of people. That's not the entire public. It's a subset, right? So if you draw a Venn diagram, it looks something like this. Oops. It looks something like this. The public, the entire public, a portion of that is, say, private. And this private can mean employees of Microsoft. So they belong here. And anybody who belongs in that group of people, if they get access to a specific cloud, which is their private cloud. That means only those that belong in the smaller circle can actually access the private cloud. It is for them and only for them. This guy outside of the Microsoft company cannot, because he's a member of the public and not a member of this private group, and therefore limited. He cannot access the private cloud because he is not in the group. That's it, as simple as that. Private cloud, limited, a subset of the people at large. Now let's go see this hybrid cloud. It basically means it is two or more distinct cloud infrastructures. You can extend this definition to mix and match between multiple public clouds and use AWS and use Google, like I do. Or you can use some public cloud and some your own infrastructure in your own company, like I do. I used to do, I should say. I used to have my own infrastructure in my company in the garage down there, and that used to run real services, like years and years ago. That was a hybrid setup. I used to use some portion of the cloud outside in the public domain, sorry, not public domain, but public cloud, and some internally hosted in my home. That is hybrid. So if you mix and match things, it becomes hybrid. So now let us see what a community cloud would be. This one. Simply think of it as an extension of the private idea, where you can have something that is not limited strictly by ownership or private nature of a business, but by shared concerns. So think of it as there is a cloud in Amazon that I don't have access to because I'm not a member of that community, but it is called the CIA cloud. There is a cloud, CIA cloud from Amazon given to CIA. There is also a GovCloud for US government. Now, I'm not a government officer in this country, so I don't have access to the GovCloud. But there is a cloud like that, and if you're a government employee and you have privilege and permission, you can access this website. And in the Oregon region that you see here, you will see somewhere here GovCloud, just like that. And if you're a government contractor, you're like many Boeing employees are, they have access to GovCloud. If you are a government employee and you have a need to access cloud, then you get access to this special button right here. And that's an example of a community cloud where people are sharing a concern of some sorts and shared concerns. Like right there. Like they're on a mission, some security requirements, some policy and compliance considerations. So that group of people that have that shared concern together have their own community cloud. That's the classification here. And with that, the deployment models are discussed. There's not much to discuss here, except it's just how you classify. Having seen this idea, what I would like to now do is close out of the session today by asking you to do certain things. First one, remember to not waste money. That's the first thing. Like absolutely never waste money. The second thing is spend money and get a domain if you don't have one already. If you have one, use it. If you don't have it, get a domain. Go to GoDaddy and you will try to look for it and you will not find a cheap domain. So what do? Well, apparently they're here telling you a 2-year purchase required. No, that's nonsense. So don't go like this. If you go straight to the website, they will not show you their cheap offers. So you go to search, and trick searches are like this. So I'll tell you the tricks. You can play a trick like something like, say, name cheap is another domain seller. $1 domain. Search like this, and suddenly you will find that GoDaddy is advertising you trying to sell you 99-cent domains. That's exactly what you want. So you click through that link and you get the offer. So get a domain. I think that's what really I'm trying to tell you, is buy a domain for only 1 year. Anything you like. Some people have just any domain you can get, any extension, doesn't matter. Get one, only for 1 year. And if you want to keep it for the second and third year, it's your decision. A domain on an ongoing basis typically costs you like $8 per year, roughly, give or take. The first year, these guys want your business, so they discount deeply and give you 99-cent domain. And GoDaddy is notorious in that they will do it this way, provided you search for a competitor. And the competitor's Namecheap is a competitor to GoDaddy. So you say Namecheap $1 domain, and GoDaddy will come and advertise you 99-cent. You can see that very easily. Just search this Namecheap $1 domain, go Google search, bang, and you will see GoDaddy. Or Namecheap itself is doing this, fine, whatever. Whoever, Namecheap is fine, doesn't matter. Any domain vendor that sells you a domain for only 1 year, take it. 99 cents is a good price. Anything more than that is a bad price. I recommend against spending anything more than $1 plus tax. Don't buy it. Don't waste money. And that's what we will use in the next session that we will have. And in the meanwhile, you have access to the website, which you probably know. This is how it looks like. You log in, and here you go to your programs of choice, and you explore, and you will have access to the begin button, and from that you can access a bunch of things. And so, by the way, here is the last video from the last time, and right below that you will find today's video that will it is getting recorded, and I just need to stop the streaming in order for the recording to crystallize and show up. It is automated, so I don't have to do a thing, because I told you I'm lazy. That video will appear right here on this page, right below the previous video I did like a few weeks ago, I think. When I announced the program, you will find this video from today also appear in the same website, and you can review it, watch it, do the things that I did, extend beyond what I did, ask questions in Slack, I will answer them. If you get stuck, if you really get stuck and you need help, ask for a one-on-one. I'll do that. One-on-one on a Zoom. I will share my desktop, and you will be able to share your desktop if you need. And you don't have to have a camera. Camera is not necessary. I have a camera. I'll show you my face if you want to see my face. Otherwise, I'll just shut off. But you don't need a camera. I use a camera because I want to show you who am I. You don't have to see my face though. Having said, ask for a one-on-one if you need assistance on Slack. Come on, chat. I'll answer your questions. And with that, I will disconnect this live stream. Thank you, and talk to you next time. Bye.